Hey, people, lesson 4. We comboed lesson 4 and lesson 5 together here. So don't get nervous that we drift into lesson 5 because there's really not a lot of extra stuff that's going on in lesson 4. Lesson 4, identifying proportional and non-proportional relationships in tables. You've been doing that. For the most part, though, they've been giving you the table and then you've been identifying it there. Here, they're like, listen, we're going to have you set it up and then figure it out. So we're still using our same idea of, do we have a constant? Are we always multiplying by the same number? All those types of things. So let's show you what we're looking at. We're going to stay with this table. I thought we were going to go further, but let's stay right here the entire time. Okay, so you decide to walk in a long distance race. There are 2 teams that can join. Team A walks at a constant rate of 2.5 miles per hour. Okay, so in 1 hour, we're going 2.5. And then because we're creating the table, we can use our repeat addition. So a 2, a 3, a 4, a 5, a 6. 2.5. Okay, keep adding on there. 5, 7.5. All right. 10, 12.5. Oops, wait a second. No, we're good. Sorry. Thought I was off there somewhere. Thought I was off. All right. And then 15. All right. So I was kind of looking for patterns there. Like the 5, skip to the 10, skip to the 15. All right. The 2.5, add a 5, add a 5. Just kind of making sure. All right. And then Team B walks 4 miles the first hour. Okay. So 1 hour they're going 4. And then 2 miles per hour after that. Okay, so I can't use the repeat addition here because it changes. 2 miles per hour after that. So an hour later, now we're at 6. Okay. An hour later, now we're at 8. An hour later, now we're at 10. Hour later, now we're at 12. An hour later, now we're at 14. Okay. So instead of going through all the list of questions, what they're asking here really is, hey, are we proportional? And what we're seeing here is, for Team B, the answer is no here. Okay. Not proportional. All right. No, not proportional. There is no constant. If we do our y divided by x, and like we said, for right now, they're going to give it to you in that order. Okay. Every single time, I'm not going to get the same number. 4 divided by 1 is not the same as 6 divided by 2, which is not the same as 8 divided by 3. So we actually put our not equal sign, which is an equal sign with a slash through it. So, yeah. Whereas over here with Team A, we're going to say yes. And if we do our y divided by x, 2.5 divided by 1, that's going to give me the exact same thing as doing 5 divided by 2, which is the exact same thing as 7.5 divided by 3. Now, because they're giving me decimals, this definitely would be calculator-based. All right, no problem punching that in. If they don't give us decimals, we typically want to stay away from it because we're going to want to use our fractions that are there. But yeah, those are all going to be the same, so we are all set to go. All right, so what we really want to get into is lesson 5 here. All right, this is where we're going to see someone a little bit newer. All right, because now we're focusing on in graphs. And we're going to see something very consistent. It is proportional in graphs if there's 2 requirements. All right. One is we're going to need to have a straight path of points. All right. Straight path of points. And the second thing is that we need to, all right, the graph needs to go through the origin. Your origin is that ordered pair of 0, 0. Those 2 things to happen based off a graph. So if we're looking at a graph like we've got right here, all right, we're going to fill in our table. So again, we're in control, so we can do some repeat addition. 2, 4, 6, 8, 3, 6, 9, 12. We can check and see if it's proportional. We can do our y divided by x, and we get a 3 halves. For the next guy, I get 6 fourths. But if I divide it by 2, we do get 3 halves. All right. Man, bad writing there. All right. The 9 6, divide them both by 3. We're still going to get 3 halves. 12 divided by 8. Let's divide them by 4. We're still going to get 3 halves. So, yes, it is proportional. But what they want to show you is like, listen, if they don't give us the data, but just the graph, can we also tell it's proportional? Well, watch what happens here. Remember, Two requirements. Straight path of points, and it has to go through that origin that's there. So here we go. So we're going to plot our points here. There's my X and there's my Y. So my X, that's the candy bars sold, and then that's the money received on the Y-axis. So I'm going to go to the right 2, I'm going to go up 3, doink. All right, to the right 4, I'm going to go up 6, doink. To the right 6, up to 9, there it is. To the right 8, I'm going to go up to 12, there we go. And so what I can kind of see is a pattern. Even though my graph doesn't show like it's going through it, we're going to continue the pattern. So if we kind of look at it, as we're going down 3 to the left 2, 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 yeah, that puts us right there. Now, if I did connect them, it would go through there, but sometimes we don't draw the best straight line. So looking at the visual that's there is definitely the case. So yeah, so here we're going to say yes, all right, because we do have that straight path of points, and we did go through that origin that we're looking at, all right? Let's see here. Yeah, let's take a peek at what we got going on here. We're going to plot these guys. Again, there's my X and my Y, so I'm going to go to the right 2, I'm going to go up 3, I'm going to go to the right 4, I'm going to go up to 6, I'm going to go to the right 8, I'm going to go up to 12, looks like I'm back at the beginning here. To the right 8, up to 12, all right, 4 up to 6, all right, to the right 2, up to 3, and then to the right 12, up to 14. So here, if I kind of connect dots, I'm kind of not a straight path of points. So because it's not a straight path of points, all right, yeah, I can just shut it down right there. It's not going to give me a proportional relationship. Remember, if we come on back over here, we do our y divided by x, I should get that 3 halves every time. And sure enough, 6/4, that simplifies the 3 halves. The 12/8, if I divide it by 4, I'm going to get a 3 halves. But if I take 14/12, if I divide that and simplify it all the way, I'm getting 7/6. And that tells me there's not a constant that's there. So again, we kind of fit the pattern that was there. All right. I was going to the right 2, up 3. So going to the right 2, up 3, to the right 2, up 3. Like, it was matching up, but then to the right 2, up 3. No, that guy did not hit it there. So yeah, that's it. Straight path of points needs to go through the origin, all right, and both need to happen. Because again, if I keep that pattern going, I did go through the origin technically, following that pattern, but I did not get my straight path of points that's there. All right, people, that's what it comes down to. Straight lines and through that ordered pair of 0, 0. All right? Bless you. You still here?